Hello everyone, this is Spiritual Successor. The basic concept is I'm a game developer, and we're trying to make a spiritual successor to Diddy Kong Racing, seeing what we would need to do. We're going to use Diddy Kong Racing as a baseline, and basically make a game that has very similar mechanics and all that fun stuff, but ultimately could take on its own identity and could become its own game if it wanted to. So yeah, let's do that. So to recap, we have a vehicle, we can move forward, it decelerates. Now, I stated in my last video, for the most part, we're not concerned about visuals. What we are concerned about is making sure the mechanics feel right first. So, got a vehicle, we can turn around. And oh, we can only move one direction. So we're going to fix that. Okay, so here's all our code for moving our vehicle. We're going to make some amendments. And yeah, so we need to add some new inputs. Fire 1, what's that? Let's change that to accelerate. So I'm going to change this to get button down, accelerate, and we're going to want a thing to back up as well. Make that X for now. There we go. So we should be able to move forwards and back up. Okay, well something's wrong there. Okay, we want it to be get button, not get button down. That's funny. Moving backwards somehow became faster. Because I used division instead of multiplication. So now I can drive forwards. We can drive backwards. But this still doesn't feel like... This still does not feel quite like Diddy Kong Racing yet. So let's take a quick look here. So we'll notice that when we turn, or when we're driving when we turn, the vehicle kind of slants and then the camera kind of follows. So we're going to try and recreate that effect just to kind of make the turns feel a lot better. So I get to figure out how to do that. You guys get to see my brain struggle, and hopefully we learn something out of it. So let's get started. So first thing we want to do is separate the camera. It's going to get its own script. So this camera needs to know where the player, or about the player. So this is how it's going to remember. And then we're going to have some code here to search for the player in the world and, you know, remember it. And then we want to follow the player on update. So we want the camera's position to always be where the player is. And we're just going to make sure we actually have some way to contact the player. Then we need to have an offset, because we don't want the camera just being right inside the player. We need a reference to the camera. So I'm going to set this up a little differently. And there we go. Got everything we need script-wise. So now let's make an object. Create empty. We're going to drag it inside the player for now. Move that out of the player again. Call this camera pivot. Our main camera's going to go inside of there. This script, we want it on camera pivot, so we drag it there, main camera. Need a reference to the player. I should name this player. Give this some basic values, but we're gonna worry about that later. So now we're literally inside the vehicle. So let's adjust the offset. Let's find an angle that looks nice. That's decent enough. I'm gonna click copy component. I'm gonna exit, paste all those values in, and let's check out this camera now. So we can drive forward. Now, currently when we turn, the vehicle does not respond, or the camera doesn't really stay behind this player. It just kind of stays locked to one spot, but it's always following its location. Let's analyze how this works again. So the camera will always kind of subtly follow, but then it corrects itself. So basically the camera needs to know when the player is trying to do a turn. And kind of loosely follow them. But otherwise, you know, kind of just stay behind them. So let's get that kind of logic in there. So got access to two values, an X and Y value, and the camera can rely on these values to know how far the player has turned, or if the player is turning in what direction. If player controller dot, I think it's X, yeah it's X, mathf dot abs, so we want the absolute value, so whether it's positive or negative, it'll kind of make it one value that is positive. So this, and the reason why we want to do that is just we want to know, is it less than 0 or greater than 0? Then we want to execute some code. So this is where we put in code to kind of have the camera operate itself. Okay, so there we go. This should hopefully manage the player rotation. And then we'll have this. So let's restart this and see how the camera functions. Okay. So not as we would expect it to work, but that's progress, so make that negative. So you might want to add an alert function here too. I'm going to move this to fixed update. That way frame rate doesn't affect the speed. Okay. So, little wonky, but we're getting there. So let's just compare. Now let's look at mine. So we're going to improve that a bit. First off, I'm going to try, you know, messing with the angle a bit. Instead of a 45-degree angle that we turn the camera, we'll try a 20-degree angle. And also have it transition faster. In hopes that that maybe changes something. So I'm going to try a different strategy here. Rather than use alert function here, why not just change the one value that I'm going to modify? So I'm going to use a method called getAccess. It uses a smoothened value, which means it gradually goes from 0 to whatever value is on the controller, rather than being instantaneous. I want to see what that happens with that. See what happens. Okay. So that's working much better. So let's compare. So I'm going to make this a configurable value called turning angle. That way we can just adjust this in the editor. And the editor's on the wrong monitor. It's got X times handling. We also need the current speed to kind of take effect as well. So I gotta do some division here. So I gotta multiply the handling by the current speed divided by the top speed. And that way, our handling or our steering speed is affected by how fast we're driving forward. So, oh, we got a error. So now if we try to turn, nothing's gonna happen. Now there's some smoothing out I gotta do, but with the camera, but let's check this out. So if we're going full speed, we can turn. So now we're going to add some more math. The camera needs to know about these values now too. Now let's see how this works. So if we're barely moving, the camera will barely turn. But if we're fully driving, the camera will have full turns. Now there is an issue where if I quickly go from one angle to another, you get this weird snapping. So I'm going to fix that. So the turning angle, we need a new value called current turning angle. And current turning angle is going to be, we're going to take this value here, or this if statement here, and I'm going to reuse it for something else. Current turning angle is equal to mathf.lerp, and take this whole value here, and we're going to put that here. Now we're going to see how that turns out. And then that value's not met. So the snapping's not so sudden now. Let's compare. So we're getting there with the camera. I think we've gotten close enough. So we need some other things. Maybe a thing that you guys may have been thinking about is, shouldn't the wheels be rotating? Shouldn't our terrible square wheels be rotating? And yes. So we're going to be rotating the x-axis, and we're going to make the rotation speed based on how fast the vehicle is moving. So let's do that. Let's create a list called wheels to spin. Now if you remember with the last video, I said we need to keep track of our front tires and back tires. We're going to add those to a new list of just wheels in general. And we're going to tell all the wheels to spin all the same. So literally all I'm going to do is for each game object, wheel in wheels to spin, we want to set their rotation. I'm going to set the rotation to, or just keep increasing the X rotation. So let's do that here. I'll do it by 1 multiplied by the current speed. So let's check that out. Let's see if it works. Oh, we used the wrong rotation. Okay, so we should have spinning wheels now. Hopefully. So check it out. Why are the wheels behaving that way? That's interesting. Seems like after the first time we let this go, the wheels just don't want to turn anymore. So I'm going to check that out. Use a breakpoint. Basically what this will let me do is let me see what's going on here. Okay, okay, never mind. I thought I figured it out. We haven't. Okay. So, I finally figured out how to get the tires to turn and keep turning. That took way longer than it should have. This should have been the easy part, but anyway, we got spinning tires. And they move based on how fast the vehicle is moving. So we're going to create another value called tire speed. And I want to edit that through here as well. We can now edit the tire speed through the editor now. So there we go. So to compare, interesting. So I didn't notice this before, but you can brake in this game, but you can't back up. So this game kind of just lets you actually kind of, oh wow. Yes, if you drive into the wall, it actually starts to guide you another direction. Damn, I never noticed that. So this game made it so you never had to back up. Look at that. Mechanics wise, this seems to be the same. So, now we need to do some ultimate testing. We need to test gravity. In Diddy Kong Racing, at least when you're in the vehicle, you don't usually run into situations where you're falling, unless you drive off a bridge or something. So, we need to make a makeshift track. Let's take the sphere, put that on the ground here, make it like Right. So right now we can't drive up anything. So remember when we set some constraints last video so we couldn't flip over? Well, we're gonna have to deal with flipping over now. But let's just see how this works. Okay. So it's not working out so well. What collider is this using? Should be a sphere. Oh? That's the first time I've seen a sphere collider not want to scale. Driving up spheres, test 2. Whoa, look at that. We're flying. So that's kind of undesirable. So I'm going to try something. We're going to increase the gravity to like -30. See what that does. So we can't drive up the terrain. Oh, now we can. So I think I figured it out. We don't have a lot of force placed on our y-axis. So I need to change how some of my code works. Let's try some terrain that's a little easier. Let's get a cube. And we'll kind of elongate it. Okay. Let's get a little ramp here. At a minimum, we need to be able to get up a ramp properly. Oh. Immediate faceplant. Now we're upside down. And now we're flying. Yeah. Alrighty. So after some pain and suffering, I finally got drifting kinda working. It'll probably need some value tweaking and a bunch of other tweaks for it to be, you know, 100% usable, but, you know. We're getting there. So just compare. Which what that might be the biggest thing is the camera positioning. That might have to be done next. So let's take a look at what our offsets could be. Okay, so we got that kind of working. We're gonna have to smoothen that out a bit. Okay. So the camera will kind of adjust itself when we drift now. And you know what? This might be a perfect place to leave everything off. So we got a vehicle that accelerates, decelerates, we can turn, the camera kind of tilts with it, we can drift. So yeah, if you liked this video, feel free to like it. If you didn't, well, you know where the dislike button is, I guess. But I don't know, I think this is kind of cool. Just trying to recreate the mechanics of another game. And like I said, this model, this vehicle doesn't look pretty, but that doesn't really matter, because as you can see, we're still getting the gist of how Diddy Kong Racing operates. We can always replace this. Oh. Okay, well, that's gonna be another issue we gotta fix, but you can always replace terrible programmer art with better looking stuff later. So yeah, I guess I'll see you guys next video, and feel free to subscribe and click the bell notification icon if you want to keep up with this stuff.